Okay, hello everybody again, and we are going now to do practice questions from chapter 14, and these questions are going to help you to warm up and do better when you start solving the problems. So let's get started, and I'm going to do the first question. So how would you best describe heat? So energy stored in the molecules, energy in transit due to temperature difference, average kinetic energy of particles, potential energy of atoms. Okay. So energy stored, energy in transit due to temperature difference, or average kinetic energy. So this is heat. So I believe B is the right answer. Okay. For number 2, so what does temperature measure? Like total energy, potential energy, average kinetic energy. So it measures the average kinetic energy. For number 3, when two objects at different temperatures touch, so where does heat flow? So the heat always, guys, flow from the cool object, from the hot object to the cool object. So it has a direction from hot to cool. So from hot to cool. Okay. So just moving from hot object to cool object, or the cold object. Okay. Number 4. So number 4, absolute zero. At absolute zero, a substance has no mass, maximum energy, zero thermal motion, high kinetic energy. So at the 0 Kelvin, the object or the object atoms will have zero thermal motion, so they are not moving anymore. Okay. Number 5. So which has more heat energy? A large iceberg at 0 Kelvin or a cup of boiling water? So you can see here you have a huge number of water molecules, but in cup of water you have less number of water molecules. So I guess A is the right answer, because the cup of water will have like less water molecules, and so more heat depends on how many molecules they have. Okay, or how many molecules the system has. Okay, and you can see that the cup of boiling water will have less number of molecules. For number 6, which unit used for measure energy? Of course it is joule. So what does specific heat capacity determine? So the specific heat determines, let's see here, how easily a material changes temperature. It is melting point, it is density, its conductivity. So I guess it is A, like how easily a material changes temperature. For number 8, during a phase change, how does temperature behave? So in temperature change, when the phase change, during that phase change, what will happen? The temperature of the system remain constant. Okay, and that can happen in the process of the phase change of the water from solid to liquid. Okay, so C is the right answer. For number 9, what is the energy absorbed when ice melts cold. So what do we call that energy? So we call that energy latent heat of fusion. So latent heat of fusion, so we have Q, latent heat of fusion, is equal to the mass of the substance or the material times L fusion. Okay, and this process actually is between solid and liquid. Okay, between those two we have this process between solid and liquid, between those two phases. So how does radiation differ from conduction and convection? Needs a medium, transfers by particles, occurs only in solids, needs a medium, needs no medium. So D is the right answer. So the radiation, actually, you can see that from this name. So it is radiation, it doesn't need medium, so it is a wave. And the electromagnetic wave actually doesn't need any medium. Okay, so it's considered as electromagnetic wave. And we will study the electromagnetic waves, by the way, when we start talking about waves. For number 11, which of the following is not a method of heat transfer? We have reflection, conduction, convection, radiation. So which one is not? So I believe reflection is not. Okay, so conduction, convection, radiation, all of these are methods to transfer heat. Number 12, what does the rate of heat transfer through a solid depends on? The mass only, thickness, area, and temperature difference, color, volume. So I believe B is the right answer. So the thickness, the area, and also the temperature difference between the two sides. That's going to help you guys to study the heat transfer through a solid material. Okay, and maybe I need here to explain something. So if we have a material like this, and we have here T1 and we have here T2, so you can see that the heat transfer depends on the thickness X and depends on delta T, which is change in temperature. So maybe this is your room and this is outside, and if you don't have like a very good isolated wall, so you can see the heat is going to go out from your room to outside if the weather outside is cold. Okay, so when we study the heat flow, we need to know the temperature difference between inside and outside, and also we need to know the thickness. Okay, the thickness of this material, and of course the area, the cross-sectional area of the wall also is very important. Okay, so number 13. So why do metals feel cold to the touch? So let's see. Absorb heat slowly, conduct heat away from the skin quickly, have like high specific heat, reflect heat. So B is the right answer. So conduct heat away from the skin, so that's why you feel the piece of metal is too cold. And if I go to number 14, so shiny surfaces are good at absorption, emitting, reflecting, and or conducting. Of course. So like a shiny surface, it will do very good work with the reflecting. So how does the earth receive most of the heat from the sun? So the heat from the sun comes in form of electromagnetic wave, and we receive this kind of energy in form of radiation. Okay, so the radiation is the right way that help us to receive heat from the sun. Okay, so these are like very simple questions that can help you guys, to warm up and just be ready to do some problems from chapter 14. So let's now go to the problems. Thank you very much.